Hi, welcome to NumPy Tutorial Series. In today's lesson, you will learn about fancy indexing in NumPy Arrays.
We already know what element indexing is.
However, in this video, we will take it to the next level. So let's start. Subscribe to Badger the Teacher and never miss new educational videos. The main idea behind fancy indexing is very simple. It is passing a list of indices to access multiple elements at once. So to be short, it's an indexing using multiple indices, not a single index.
That sounds interesting.
For example, if you have an array with three integers 1, 2 and 3, their indices are 0, 1 and 2. We can access both element at index 1 and element at index 2 by passing a list of these indices. The result is an array of two elements, 2 and 3. The second example accesses elements at indices 0 and 1 both at once. So the result is an array of two elements, 1 and 2.
Let's check how fancy indexing works in two-dimensional arrays.
In this example, we use an array of 3 rows and 2 columns. The values are in the table for your convenience. We then create two NumPy arrays, rows containing row indices to retrieve and cols with a column index. So we want to get elements lying at rows 0 and 2, column 1. These values are 2 and 6.
I guess I can do it without rows and cols variables, directly passing arrays or lists of indexes. The result is identical.
As you see, there is only one index in column index list, so list looks a bit redundant there.
Can we get rid of array in this case?
Yes. You can actually combine fancy indexing with basic element indexing as in this example. We index several rows and only one column, so we don't have to use an array for column indices. It's okay to pass just one to address column at index 1.
Now it looks better. Can we modify elements by using fancy indexing?
Sure. You can not only read several elements at once, you can also modify them.
So, in this example, 0 is assigned to the elements at indexes 1 and 2 just in one line. That's very handy.
Fancy indexing can be combined with slicing as well. For example, here we pass 2 rows and all columns.
If you are wondering why did we get all the columns and how slicing works, please watch the lesson on slicing. The link is in the description.
One of the many situations where to use fancy indexing is, for example, when you have to choose some random points from an array. Let's say we have two-dimensional array and want to select random indices from it. We can use random.choice function and pass the number of rows, the number of columns, and an indicator whether to include or exclude duplicates.
Could you remind me how do we get the number of rows and columns in the array?
To obtain row number and column number, you can use, for example, shape attribute. Element with index 0 of shape attribute is row count, and the element of index 1 is column count. Replace equals to false guarantees only unique indices.
So the result is 2 rows, 3, 4 and 5, 6.
Rerun choice function and you will see its generated results are different.
Let's compare the result if replace parameter value is true.
This is the same example, except that replace is equal to true. So you see, result contains duplicates this time. 2 rows with values 5 and 6. Take and put functions is another way of getting and modifying several array elements at a time. In this example, we have one-dimensional array of 3 integers.
Then we see an array of 2 indices is initialized, index 0 and 2.
Right, with take function we can get these two elements, 1 and 3 is the result. With put, we can update several element values at once. For example, we have inserted zeros at indices 0 and 2. That's it for today.
We have covered an amazing technique. I will definitely have to practice this approach.
In the next lesson, we will see other very powerful way how to address elements, masking. Please subscribe to Badger the Teacher and don't miss new lessons. See you in the next lesson. Bye!